Right now, deep in the California desert, an aircraft may exist that could cross the United States faster than most people drive to work. Imagine flying from New York to Los Angeles in just 12 minutes. That's not just fast, it's mind-boggling. The SR-72 Darkstar isn't merely breaking speed records, it's redefining what we thought was possible. Mach 6. 6 times the speed of sound. So fast, enemy missiles wouldn't even have a chance to track it. And the most astonishing part? It may have already taken flight. Lockheed Martin's Skunk Works, the legendary engineers behind the SR-71 Blackbird, have been quietly building something extraordinary. Their silence isn't accidental. When Lockheed goes quiet, it usually signals a game-changing breakthrough. The SR-72 isn't just another plane. It represents the next era of American air dominance. Its development brings hypersonic flight out of science fiction and into reality. While Russia and China boast about their hypersonic missiles, the United States has been quietly working on something far more formidable, a reusable, optionally manned aircraft that doesn't just touch hypersonic speeds, it lives at them. This is advanced engineering, cutting-edge technology, and American innovation at its finest. The Air Force isn't broadcasting it to the world, but the clues are there if you know where to look. If you're as fascinated by America's hypersonic capabilities as we are, leave a comment below and share your thoughts on the SR-72.
The legend that started it all, SR-71 Blackbird. To truly understand the SR-72, we need to revisit its iconic predecessor, the SR-71 Blackbird. This wasn't just any aircraft. It was the plane that made the impossible routine. Capable of Mach 3.2, over 2,200 miles per hour, and flying at altitudes exceeding 85,000 feet, it evaded every threat. During its service, over 4,000 missiles were launched at it, and not a single one hit. Why? The strategy was simple: fly faster than anything chasing you. And it worked every single time. Designed in the 1960s by Kelly Johnson and his Skunk Works team, the Blackbird was so advanced that even today, decades after its retirement in 1998, no publicly known aircraft has surpassed its speed. To put it in perspective, your smartphone now holds more computing power than the entire Apollo program, yet we still haven't beaten the SR-71 speed record. Until, perhaps, now. The Air Force retired the SR-71 not due to obsolescence, but because of operating costs, about $200,000 per flight hour in the 1980s. However, the need for such unmatched speed never disappeared. Speed and altitude provide an advantage stealth alone cannot: the freedom to go anywhere, anytime, without interference. That's exactly where the SR-72 enters the picture. What it promises is nothing short of revolutionary. Why Mach 6 matters: the hypersonic arms race. Before we dive deeper into what makes the SR-72 truly revolutionary, it's important to understand the bigger picture, the current hypersonic arms race. Why does Mach 6 even matter? Let's put it in perspective. At Mach 6, the aircraft is traveling around 4,600 miles per hour. That means it could reach Moscow from Washington, D.C. in under 90 minutes, or fly from California to Japan in less than an hour and a half. In fact, you could cross the entire continental United States in less time than it takes to watch a standard-length movie. But this speed isn't just about beating travel times. It's about survival in modern warfare. Today's most advanced air defense networks, like Russia's S-500 and China's integrated radar systems, are built to detect and eliminate stealth aircraft. These systems improve every year, investing billions into counter-stealth technologies. Here's the catch: even the most sophisticated radar can't keep up with sheer speed. At Mach 6, the SR-72 moves so fast that by the time a radar detects it, calculates a firing solution, and launches a missile, the plane has already vanished. For radar operators, It's as if they're seeing where the plane was, not where it is. It's like trying to swat a bullet in midair. And speed isn't the SR-72's only advantage. Unlike the SR-71, this aircraft isn't just for reconnaissance. It's being designed to carry hypersonic strike weapons, meaning it can infiltrate the most defended airspace, gather intelligence, and deliver precision strikes all before an enemy even realizes it's there. Before we break down the engineering behind this marvel, take a moment to like this video and subscribe. Over 98% of viewers never hit subscribe, but it costs nothing and helps us bring you more cutting-edge military tech.
The engine that makes hypersonic flight possible. Now, let's talk about what powers this incredible speed. Here's the problem with hypersonic flight. Normal jet engines simply can't handle it. Standard turbojets or turbofan engines, like those in an F-35 or commercial airliner, max out around Mach 2.2. Push beyond that and physics starts to fight back. Air compression, extreme temperatures, and airflow issues make ordinary engines ineffective. Beyond Mach 2.2, conventional jet engines simply can't keep up. The air becomes too compressed, temperatures soar, and the engine can no longer function. On the other hand, scramjets, supersonic combustion ramjets, can handle hypersonic speeds, but they come with a catch. They cannot operate at low speeds. A scramjet needs to be moving around Mach 4 before it even ignites. That's why experimental scramjet vehicles are usually launched from rockets or dropped from high-flying aircraft. So how do you build a plane that takes off like a normal jet and then accelerates to Mach 6? The answer? The turbine-based combined cycle engine. This is where Lockheed Martin and their partners at Aerojet Rocketdyne truly earned their stripes. The TBCC merges a conventional turbine engine with a dual-mode scramjet in a single propulsion system. They share the same inlet and nozzle, but each has its own airflow path. Here's how it works. The aircraft takes off under turbine power, just like any ordinary jet. As it pushes past supersonic speeds and nears Mach 3, the system begins a seamless transition. Airflow gradually shifts from the turbine to the scramjet, and by Mach 4, the scramjet fully takes over, propelling the aircraft to Mach 6 and beyond. In June 2017, Lockheed Martin's Rob Weiss announced that testing of this revolutionary propulsion system was complete. They had solved one of the most challenging problems in hypersonic flight, the turbine to scramjet transition, surviving the hypersonic inferno. At Mach 6, the aircraft itself faces extreme challenges. Flying this fast isn't just about cutting through air. It's a battle against physics itself. Air molecules can't move out of the way quickly enough, compressing against the aircraft's leading edges and generating intense heat, hot enough to melt steel. The SR-71 handled Mach 3 speeds with titanium construction, expanding several inches in flight as the metal heated. Its fuel tanks even leaked on the ground, sealing only at high temperature. But titanium alone cannot survive Mach 6. The SR-72 requires something far more advanced. Carbon-carbon composites, the same material used on the space shuttle's thermal protection system and intercontinental ballistic missiles. These can endure temperatures that would instantly destroy conventional metals. Lockheed is exploring two approaches. One, a cold structure, like the space shuttle, with heat-resistant tiles protecting a cooler inner frame. The other, a next-generation titanium structure, even more heat-resistant than the SR-71.
Fuel for hypersonic flight. The SR-72 will likely use JP-7 fuel, developed originally for the SR-71. JP-7 isn't just fuel, it also acts as a coolant, flowing through channels in the aircraft's skin to absorb extreme heat before being burned in the engines. It's so stable, you can't even ignite it with a match. Every system on the SR-72, from engines to avionics, is engineered to survive conditions that would obliterate a normal aircraft within seconds. JP7 isn't ordinary fuel. It works as a coolant first, pumping through tiny channels in the SR-72's skin to soak up heat before it ever reaches the engines. It's so stable, you could literally pour it on a table and try to light it with a match. Nothing would happen. The SR-71 needed a special chemical igniter just to get the engines started. Every single system on the SR-72 must survive conditions that would reduce a normal jet to molten scrap in seconds. The radar, sensors, electronics, wiring, everything has to operate in temperatures that can blast past 1,000 degrees. And somehow, Lockheed Martin is making it all work. But there's one more twist most people don't expect. Unmanned, but not out of control. Here's where the SR-72 breaks from tradition. It isn't designed to carry a pilot. But don't picture a slow, remote-controlled drone. This is an autonomous aircraft built to make high-speed decisions on its own with human oversight, not human hands on a joystick. Why build it unmanned? 3 major reasons. 1. Humans limit performance. A pilot needs pressurization, life support, an ejection seat, and they have to survive the insane G-forces that come with hypersonic maneuvering. Remove the pilot, and the aircraft can push far beyond human physical limits. 2. Reaction time. At Mach 6, you're covering nearly a mile every single second. No human can react fast enough to handle failures or threats at those speeds. An onboard computer can make split-second decisions thousands of times faster than we can. 3. Safety and cost. If something goes wrong during testing, and hypersonic testing is always risky, you aren't losing a highly trained pilot. That single fact alone makes unmanned design almost unavoidable. But here's the interesting part. Although the SR-72 is built to fly without a pilot, early reports hinted it may be optionally piloted. That means in certain missions or during critical test flights, a human could still take the controls. The Air Force won't confirm it, but it fits the pattern. The US military likes keeping a human involved in high-stakes decisions. A hypersonic aircraft that can switch between autonomous and manned modes would give unmatched flexibility. And that leads to the real question. What would this aircraft actually do that satellites and other intelligence systems can't? Missions and capabilities. The SR-72 isn't just a fast camera platform. It fills gaps that no other system on Earth can cover. Satellites are powerful, but they follow the same orbits every day. Our rivals know exactly when they pass overhead, so they hide anything important. The SR-72 has no orbit, no schedule, and no warning. It can appear over a target within an hour, even if it launched from the opposite side of the world. There is no way to prepare for that. An enemy could set up a missile battery, launch it, and be gone before conventional aircraft could even react. The SR-72 changes the game completely. It can detect, track, and even engage threats in real time, spanning an entire continent in minutes. Hypersonic strike capability. Lockheed Martin has confirmed that the SR-72 is designed to carry the high-speed strike weapon, a missile that accelerates even faster than the aircraft itself. At Mach 6, imagine the sheer kinetic energy. One strike could neutralize targets before any defense system has time to react. Today, no radar or missile defense can reliably stop it. But the real power isn't just speed, it's deterrence. During the Cold War, the mere presence of the SR-71 over Soviet skies created a psychological advantage. The Soviets could track it, attempt to intercept it, but it always completed its mission and returned safely. That knowledge alone shifted the balance. The SR-72 brings that same concept into the 21st century, but amplified, faster, armed, and nearly unstoppable. It redefines contested airspace, sending a clear message: America can enter and exit without opposition.
Is the SR-72 real? Evidence and clues. So, is the SR-72 an actual aircraft or just another high-tech pipe dream? Let's examine the evidence. In November 2018, Lockheed Martin stated a prototype was expected to fly by 2025. Here we are in 2025, and although no public flight announcement has been made, history shows this is not unusual. The F-117 stealth fighter operated secretly for years before the world knew it existed. In 2021, Lockheed opened Building 648 at Skunk Works in Palmdale, California. This isn't a standard lab. It's a high-tech production hub for digital engineering, automated manufacturing, and rapid prototyping. Companies don't build a facility like this for a theoretical concept. Financial disclosures reinforce the picture. Since 2022, Lockheed has reported over $335 million in cost overruns on a classified aeronautics program. The workforce at Skunk Works has also more than doubled, from 2,500 employees in 2018 to over 5,500 in 2023. Clearly, they are building something substantial. And what about official statements? Lockheed executives don't deny the SR-72. They carefully talk about working on hypersonic technologies and next-generation reconnaissance, which in the defense world is about as close to confirmation as you'll get without classified clearance. The Top Gun Darkstar connection. One of the most intriguing clues comes from Hollywood. Skunk Works engineers collaborated on the Darkstar design for Top Gun Maverick, constructing a full-scale mock-up. It was so realistic that Chinese intelligence actually repositioned satellites to photograph it, believing it could be a real aircraft in development. Lockheed has even highlighted on social media that the SR-71 remains the fastest acknowledged air-breathing jet aircraft. Notice the word acknowledged. It's telling. Every clue, from the secret facilities to workforce growth, financial commitments, and Hollywood collaborations, points to the SR-72 being real, deep in advanced development, and possibly already having completed secret test flights. The real question isn't whether it exists, it's when the Air Force will officially confirm it. What it means for America. Here's the big picture. While adversaries are investing in hypersonic missiles that launch once and are gone, America is quietly building a reusable, mission-flexible, hypersonic aircraft. This isn't just about speed, it's about redefining the rules of aerial warfare. The next generation of air dominance won't rely on stealth alone. It will rely on speed and flexibility that make modern defense systems almost irrelevant. The SR-72 represents a once-in-a-generation technological leap. Remember, the SR-71 served for over 30 years and set records that still stand. The SR-72 could surpass that, providing capabilities beyond what satellites, missiles, or traditional aircraft can achieve. For those who lived through the Cold War and saw the Blackbird redefine possibility, the SR-72 is proof that American innovation hasn't slowed. It shows that when the military and aerospace industry collaborate, they can still produce achievements the rest of the world can only imagine. The hypersonic arms race is not just real, it's accelerating. America isn't merely keeping pace, we're about to lap the competition. The SR-72 Darkstar isn't just a plane, it's a statement that American air power is unmatched, that our engineers and military planners remain the best in the world, and that, in protecting our nation, we don't just respond to threats, we stay decades ahead. If this deep dive into the SR-72 amazed you as much as it did us, smash that like button and subscribe for more on cutting-edge American military technology. Drop a comment and let us know. Do you think we'll see the SR-72 in action soon? Thanks for watching, and we'll see you in the next deep dive.